In this paper, we first create two new time-specific language modeling datasets from unlabeled text in news and Twitter domains. We randomly sample articles and tweets from specific time periods to create the WMT language modeling dataset and the Twitter language modeling dataset. These datasets are designed to provide a comprehensive overview of language use in these domains over the past decade. Next, we fine-tune language models on these time-stratified datasets and analyze temporal misalignment. We use T5 small, T5 large, and T5 to 3B models, fine-tuning them on each of the time-stratified datasets using the LM adaptation objective. To reduce the computational burden, we employ low-rank adaptation, LoRa, and merge LoRa weights back into the base model before subtracting the pre-trained model. We then explore different ways of interpolating between time vectors to generalize to new times. By computing the interpolation between two time vectors through a weighted sum of the vectors, we can evaluate the performance of the interpolated models on intervening times by sweeping over different interpolation weights. We also measure temporal misalignment across various domains, tasks, and timescales. Our analysis reveals linear patterns of degradation in each task for all model sizes on a yearly scale. On a monthly scale, we find nonlinear patterns that correspond to the cycle of months in each year. Finally, we analyze the weights of time-specific models and use time vectors to update models to unseen times. We find that the weights of time vectors become less similar as the times they were fine-tuned on become more misaligned. We use time vector analogies to update models to intervening, future, and multiple time periods. Our evaluation shows that interpolating between time vectors improves performance on unseen intervening times and future times. However, building a multi-year model using a soup of time vectors does not perform as well as a model fine-tuned on all times at once.